what we are going to see in this video is the Laplace transform of the step function. Okay, before doing that, I have to tell you what is a step function. The step function definition is something like this. U of t minus a is a composite function where it is going to be 0 when t is less than a, and then 1 when t is greater than a. Alright? Now, what happens here in the plot is something like this. When the time is equal to a, here, imagine that this is a, before that is going to be 0, and after that this turns to be 1. Okay, so 0 before a, 1 after t is equal to a. Now, this is in engineering, this is called also the in the other way, off on function. Because it's very similar when you turn on your cellular phone, before this is off and then it is on. Or when you turn on the light. Right? So this is a very common function that we use every day, although we don't know. Okay, now the value of a could be 0 or could be positive, but cannot be negative. So here the a has to be positive. A has to be positive. The only thing that can be is equal to 0. So when you have u of t, when a is equal to 0, we are talking about this function. 1. Okay? So there is no 0, right? So this is 0 and this is 1. So there is no 0 because t is, with the value of a is equal to 0. Okay, now what we are going to do is apply the Laplace transform of this function. Okay, so we are going to do the Laplace transform of the step function. Step function okay. In Spanish we will be like la función escalón, but this is just the Laplace transform of t minus a. Okay, now, because we don't have a formula for this, what we have to do is to apply the Laplace definition. So the Laplace definition is the integral from 0 to infinite exponential minus st, and then here the u of t minus a. Okay, because it is a composite function, what we have to do is we have to make split this integral in two. What I'm going to do is to split the integral on this section and then on this section of the function. So it's going to be the integral from 0 to a exponential minus st. Here from 0 to a the function happens to be 0. This function is 0, differential of t, and then plus the integral from a to infinite exponential minus st, and then here 1, differential of t. Okay. Here, because from a to infinite, the function happens to be just 1. Now, this integral happens to be 0, so we don't care about this part of the integral. What we are going to do just look at this part of the integral. Okay, so the Laplace transform of the step function is equal to integral from a to infinite exponential minus st. Now we have to complete the integral. So we need a minus s here and minus 1 over s. Remember that the s is a constant for the t variable. Okay, so this is going to be minus 1 over s exponential minus st, and then from a to infinite. Okay, now let's do the upper limit minus the lower limit. So it's going to be minus 1 over s, and here is going to be exponential minus infinite, and then minus exponential minus sa. Now the exponential minus infinite, as you know, this is going to be 0. Okay, so what is left? Okay, so from the beginning we have the Laplace transform of u of t minus a, and then equal to minus times minus positive exponential of minus as over s. Okay? So this is the formula of the Laplace transform of the step function. Alright, now, again, the value of a is variable, and it can be later or can be sooner or later, but the lowest that can be is 0. Okay, now, why it cannot be 0? Well, it cannot be 0 because the Laplace transform is defined from 0 to infinite. So it is defined from here to infinite. So you cannot go before in the negative part, because that is not the definition of the Laplace transform. All right. So that is one of the reasons that the a should be greater or equal to 0. Now, what happens if it is equal to 0? So what if a is equal to 0? So what will happen? It will be the Laplace transform of u of t, because a is equal to 0. This on the left side, but on the right side is equal to exponential minus 0 s over s. Exponential of 0 happens to be just 1. This is 1 over s. Now, I'm sure you have seen this Laplace transform. This is the Laplace transform of 1 equal to 1 over s. Alright? Now, it makes sense because it is just 1 after t equal to 0. So it's the same as the Laplace transform of 1. Alright? Now, this is just to test that actually the formula makes sense when t is equal to 0, when a is equal to 0. But the important thing is this part of the Laplace transform. Alright? Okay. On the next video we are going to see how to build functions using the step function and making the Laplace transform of that. Alright? See you on the next video.